Neumann, and he was a pure mathematician, and he was reputed to have been, when he was alive, the smartest man on earth. A lot of genii met him and came away with the impression that his was a superior intellect, and that happened with virtually everybody. So he took quantum mechanics, studied it, and then reformulated it in the form of something called Hilbert space, which is a certain kind of vector space. So the idea is that you can rewrite, you can reformulate wave functions as vectors. So that idea will become stronger and stronger as the next few sessions pass. Okay. Now, it's at this point I got rather frustrated by Davies and Betts. They provide a kind of quasi-physical argument to motivate a particular aspect of this vector way of thinking of quantum mechanics, and I found it so unclear. And I read it, and I got really frustrated. If I were the wife, and a physicist, I would have asked Davies to rewrite that particular portion, because it really wasn't clear. So it doesn't really matter much. It's more just a motivator for a particular topic in the next session. You can't see it yet, but in the lower part of this part of the board, there's something called the overlap integral. Okay, and we'll do it next. But it's this discussion, this sort of physical discussion here, is really just a motivator for that concept. Don't worry about it too much. But if you're studying this thoroughly, you've got the textbook, and you're really taking this course seriously, then I'm wondering if you'll have the same confusion and frustration of the lack of clarity in what he's saying as I did. It doesn't really matter too much, even if you just gloss over it. But I get frustrated. I like to understand things. I like to have clarity. That's why. Well, I guess I share the pure math people's. They tend to look down on the lack of clarity, lack of rigor of the mathematical physicists. Mathematicians are much tighter, much more rigorous in their way of reasoning, and they don't like the sloppy, woolly thinking of physicists. And in this particular case, I feel the same. Right, the pure mathematician in me doesn't like this sort of thing. But it's just in passing. It doesn't really matter much. It's just an initial motivator for use of the vector way of thinking, or vector representation, technical term, of quantum mechanics. Thinking of wave functions as vectors. That's the essential idea for the next couple of sessions. Right? Okay. Well, we've talked about this before, way back, very early on in this course. Imagine a box. You've got one particle in the box with its wave function, and then you partition the box. Imagine the box has a kind of trapdoor. So the trapdoor falls, and now the box is partitioned into two parts, two volumes, the volume A and volume B. Okay. So in that context, this is what the rest of this session is talking about. Now, what's not clear to me, although there are hints in the next session, is just what these psi1 and psi2s are. I mean, that's what he didn't talk about too much. But he says, let the box have a wave function that's a superposition of two wave functions, weighted, your C1, C2, your usual complex numbers. And what he didn't make clear is this wave function, is that what exists before the trap falls, or after? It was not well expressed, not clearly written. I mean, I might be wrong. Judge for yourselves. Read over that passage again and again, and ask yourself, what's he talking about? Anyway, so this is my interpretation. Okay, this is me judging what he said. So because I always have to I always have to précis, right? I can't write out the whole book on the board. It'd take too long. I have to extract what I see as the essence of what he's saying and précis it, you know, shorten it, and put it on the board. So my interpretation is you have a superposition of two wave function, so the result giving you psi, and that's the state of the system, you know, your particle in your box before the trapdoor falls, right? And then but my question then is these two psi functions, do they have non-zero values over the whole volume, or because there are clues in the following the following session that he talks about psi I, like the ith, and it's the wave function of the ith volume. Now here we have just two volumes, you know, after the trapdoor falls and partitions the box into volume A and volume B. So so do I interpret this psi1 as the wave function in volume A only, and it's zero elsewhere? That's the impression I get, is what he's saying, implied. Anyway, so after the trapdoor falls, and here I'm glossing things over, and you'll probably get frustrated as well. But anyway, this is what's in the text. Okay, so the trapdoor falls. Right? So now you have two non-overlapping fragments. What does he mean by that? So two wave functions, psi1, C1 psi1 and C2 psi2, C2 psi2. That's what's in the text, and in fact in the text he had psi1 is naught, and then in A, and psi2 is naught in B. Right? That didn't make sense to me, so I reversed it. Like I say, I was frustrated by this part of the text. Anyway, so it doesn't really matter, the physical interpretation for this part. It's really just a motivator, as I was saying before, to this thing in the next session called the overlap integral. But anyway, so assuming the superposition, and you then normalize it, so you'll get, and it's over the volume of the whole box, right? dt, this is your differential of the volume of the box, and your psi here is your superposition psi, and you do the math, and you'll get this. Okay. Now, since I've run out of board for this session, but he will then normalize this for volume A and this for volume 2, volume B, and get for this the C1 squared is probability of finding the particle in volume A, and C2 squared is the probability of finding the particle in volume B, and it's either one or the other. So C1 squared plus C2 squared equals 1, and therefore this term here, this term particularly, has to be 0. And it's this term, as we'll see in more detail in the next session, it's this term here that gets labelled, is called the overlap integral. And in this case, for this box thought experiment, Gedanken experiment, has to be 0. Well, we'll continue on next session.